In quiz 11, we've got the amount of grass clippings in pounds in the bin after T days. So we start off with 6.687 pounds of grass clippings. And it's decreasing by, let's see, 0.93 by about 7%, by 6.9% per day. So it's decreasing exponentially. I guess the grass clippings are decomposing into something else, and then they're no longer grass clippings, they're something else. So this is the amount of grass clippings in pounds in the bin after T days. All right, this is a calculus class. There are two things that we might want to know about this function. We might want to know about the derivative, the rate at which grass clippings are decomposing. So the derivative of an exponential function is going to be 0.931 to the t. With the derivative of 0.931 to the t is 0.931 to the t times the natural log of 0.931. That's just one of our basic rules for taking derivatives of exponential functions. The reason that the derivative of e to the x is e to the x is that the natural log of e is equal to 1. So if I do 6.687 times the 0.931, so if I do the 6.687 times 0.93, natural log, yikes, natural log of 0.931, we're going to get negative 0.478 times 0.931 to the t. It makes sense that we got a negative number because this is a decreasing exponential function. And so the derivative will be the rate at which the grass clippings decompose in pounds per day. So this is rate at which grass clippings decompose, measured in pounds per day. It makes sense that this value will always be negative because the grass clippings are decomposing. We're not going to end up with more grass clippings. So it makes sense. It makes sense that A prime is negative since A is decreasing. So that fits with our understanding of how derivatives work. So one of the first question actually says, find the average rate of change. So the average rate of change will just be the beginning and the end. If we look at the graph of this, function, it's going to be a decreasing exponential function. Starting off at 6.687. Yikes. So we're going to have this decreasing exponential function. And it will just kind of flatten out towards the t-axis. Kind of want more decrease there. So we're going down to 30. And the first question is asking about the average rate of change of A of t. The average rate of change will just be the slope between these 2 points. So this point here will be at 30 and A of 30. So I guess we should have that value. So 30, 6.687 times 0.931 to the 30th. So we're just evaluating the function. After 30 days, we'll have 0.783 pounds of grass clippings. The average rate of change will just be the slope of the line connecting those 2 points. So the average rate of change will just be the slope of the line segment connecting those 2 points. We use the derivative for the instantaneous rate of change. So I should go back up here and clarify, this is the instantaneous rate of change. That's the rate of change, that's the speedometer, the decomposometer, to tell us how fast things are going at a particular time. So for problem 1, just calculate the slope of the line between those 2 points. For question 2, we want the instantaneous rate of change at 15 days. For question 3, we want the average amount of grass clippings. We need the average value of a function. So if we look up average value, if we think about averages, for an average, we add everything up and then divide by how many things are there. So if I wanted the average score of the students in this that are in the Zoom call right now, I would add up your point totals and then divide by 7, since there are 7 students here. Now, we're dealing with a continuous function, so we have to add things up in a different way. We can't just divide by an infinite number of things. So what we're going to do is, say, from A to B. The average value of a function on an interval from A to B, we add things up by integrating from A to B of f of t dt, and then we divide by how many days went by. So this is the formula for the average value of a function. We just need to apply that to this function here. So in this case, the average amount of grass clippings from t equals 0 to t equals 30 will just be the integral. Oops, I needed space before that. It's a little bit too aggressive with my integral writing. We'll integrate from 0 to 30 the amount of grass clippings and divide that by the number of days that have passed. Since this will be, when we integrate a of t dt, we get pound days, but then we divide that by days, so the days cancel out. So this would just be in pounds. So just calculate that definite integral and divide by 30. That's the average value. So find the time t at which the average amount of grass clippings in the bin is equal to the average amount, the amount of grass clippings is equal to the average. So we just have to take that sentence and turn it into an equation. We want to find out when is the amount of grass in the bin equal to the average amount. So we just need to solve a of t equals whatever we got from here. And that'll tell us on the teeth day, whatever that happens to be, that's when the average amount, the amount of grass clippings in the bin was equal to the average. Any questions? Yes, we can absolutely use Math 9 on the old calculating machine, because that'll hold all the rounding off until the very end. So you should definitely do that. Since we have the questions were, I wanted nice, concise questions with definitive answers that we could just type into our machines. We miss out on the interesting discussion aspects of things. Like, will we hit the average halfway through, or past halfway through, or before halfway through? Does the average happen early, or does the average happen late? That was the same thing that was going on with a prime of t versus the average, a prime of 15 halfway through versus the average rate of change. So is it going to be steeper or flatter than the average rate of change? And why would that be? So if you want to think about the interesting questions that are going on here, you really want to look at the concavity of the function and compare that to the lack of concavity when we're just calculating an average rate of change. I think there was a fifth question, which was, at this point, when t is equal to 30, turn this into a line. So just calculate the slope of the tangent line at 30, and then make the equation of the line with this point and find out when that's equal to 0.5. Any questions? Great, let's pause the video here. Let's pause the video here and talk about other things. Incidentally, the suggestion to use Math 9 on your calculator is directly on point, because that's the reason that we have these numbers here. I would not, you can tell that I didn't write this problem because I would not have been picking this number. I would have been like all 7.9, just to decrease the amount of things. But the reason that these numbers are going all the way out to the thousandth is that the source of this problem was this problem was written to involve a calculating machine. This was written with you having access to a calculator. Because I stole this problem from a famous test that you may have heard of, but not the SAT. The SAT can't have calculus on it. No one would ever get a good score. All right, let's pause the video here. Talk about other things.